Hello everyone, I am Dr. Velmani P.S., Professor, Department of Computer Science, University of Science and Technology, Meghalaya. In this video, we are going to see about machine to machine towards IoT, the global context. The contents are M2M towards IoT, that is machine to machine communication towards Internet of Things. The second one is global changing with IoT. The third, that is general technology and scientific trends. The fourth one is wireless sensor under sea monitoring. The fifth one is trends in information and communications technologies. M2M towards IoT. A set of mega trends are combining to create needs and capabilities, which in turn produce a set of IoT technologies and business drivers. A mega trend is a pattern or trend that will have a fundamental and global impact on society at a macro level over several generations. Game changers. The game changers come from a set of social, economic, and environmental shifts. So, the global changing with IoT. So, the various constraints, various areas, how it can be happening. The world is becoming the IoT trends in various sectors and various environments. Number one is natural resource constraints. The IoT is used to increase the yield, improve productivity, and decrease loss across globe supply chains. That is, distribution is therefore escalating. Economic shifts. The overall economy is in a state of flux as it moves from the post-industrial era to a digital economy. As technology becomes increasingly embedded and more tasks automated, countries needs to manage this shift and ensure that M2M and IoT also create new jobs and industries. So the new job opportunities also is going to be happen with this new technology IoT. Changing demographics. Many countries need and also it deals with an aging population without increasing economic expenditure. As a result, IoT will need to be used, for example, to help provide assistance, living and reduce cost in healthcare and emerging well-care systems. So, to develop the well-care system in the demographics, and there is a need of IoT implementation in this throughout the world. Socio-economic expectation. So the lifestyle and convenience will be increasingly enabled by the technology as the same disruption and efficiency practices evident in industries will be applied within people lives and homes as well. So socially this is also creating an impact of using the IoT technologies. Climate change and environmental impacts. Technology, including IoT, will need to be applied aggressively, reduce the impact of human activity on the Earth systems. Then the safety and security. Public safety and national security becomes more urgent as social becomes more advanced, but also more vulnerable. So some of the things like prevention and different technologies can address a number of the issues. Urbanization. So urbanization creates an entirely new level of demands on city infrastructures in order to support increasing urban population. So IoT technologies will play a central role in the optimization for citizens, and it also enterprises with the urban realm, as well as providing increased support for decision makers in the city levels. Now the general technology and scientific trends. So the general technology, material science, also we are using this. Then the complex and advanced machinery, also we are using this. So in the material science, the micro electromechanical systems can be used to build advanced micro-sized sensors like accelerometer and gyroscopes. We'll see this accelerometer and gyroscopes, how this can be available in the form of hardware device equipment. So the new materials provide different methods to develop and manufacture a large range of different sensors and actuators, as well being used in applications for environmental control, water purification, etc. So this is the material science, and we'll see this sensor and sensors like accelerometer and gyroscopes in the further slides. So the complex advanced machinery, it's autonomous or semi-autonomous. So the individually it is having the capability to control the environment and to uh, get the information from the live environment information. Accordingly, the machines will act. So today these are used in a number of different industries. Example is robotics. The robots are very advanced machinery which is used in different harsh environment such as deep sea exploration or in the mining industry in solutions such as Rio Tinto's mines of the future. So now the accelerometer and gyroscopes. So how this is, so this particular device is the accelerometer is a kind of sensor tool that measures the acceleration of any body or object in its instantaneous rest frame. It is not a coordinate acceleration actually. So the x, y, z, so three coordinates will be there. See the roll, which is going to one single roll, which is going to be rotated in the x axis, title right or left. So right or left, if it is right or left, that can be a single rotation. The pitch, the rotation on y-axis tiled up or down, that is in y-axis. So the x-axis, that is right or left rotation. This is rotation on y-axis, that is for a pitch. Then the rotation on the z-axis, that is accelerometer, cannot measure. Yeah. So this is the consideration which we can see to it in the accelerometer. Then the gyroscopes, how this can be, and the this particular device sends angular velocity, which is the change in rotational angle per unit of time. This angular velocity is generally expressed in degree per second. So again, the y plus, then the x plus and z plus. The rotations, based upon the rotations, the velocity will be calculated. And also it is measured in degree per second. So in this figure, wireless sensor under sea monitoring. So the sensor is going to monitor under the sea. So now let us take the from the bottom area sensor node. From the sensor node, the observation of the bottom of the sea to the sink node. The information will be passed to the sink node, that is the nearest one. So from the sink node, it is going to connect with the gateway. Again, we can have the several sensors, and also it takes place the movement by the ballast tank, like in such a fashion. So this can be bidirectional. This from this sensor node, the wireless power transmission can be happened. The wireless power transmission module. So this is the wireless transmission module, and these are all the movement by the ballast tank. This is the tank which we can see it in the sensor node. So now how the power management is going to be happen in the gateway, we'll see to it. So from the sensor node, the environment observation can be done, and based upon that, this transducer will convert the signal, and the solar cell will produce the energy, and this will be controlled by the personal computer from the user side through the gateway, and the power management will takes the battery backups, and the small battery charge controller will control the battery power, and wireless power transmission will happen to this sensor node, and automatically it moves from this activator takes place just opposite action, which is opposite to the transducer. The process will be performed, and the bidirectional action can be done. And with this, the power management will be properly handled by the user in the personal computer. So in this way, under the sea level, we can monitor, and also at the same time, the sensor node will get the power supply. Now the forest mapping robots. So these in these robots, how the forest can be mapped. Let us have a look on this. So this particular round which we are marking here, that is environmental perception, which is having a depth camera and a laser sensor and a lidar, which is light detection ranging. So light detection and ranging, by using the depth camera, the laser sensor will be used in this particular cameras. Then the drive system, the electric drive, the hydraulic drive, the pneumatic drive, and this new drive also will be used to uh, make some movements in this particular robot. So in case of moving right or left, accordingly this hydraulic drive system will be operated. Then the controlling strategy, so the how to control this drive system, so by using this PID control. This PID is nothing but a proportional integral derivative controller, so it can monitor the environment properly, and also it is having the neural network control and fuzzy control, non-linear control. So by using these control methods, and this particular robot can observe the environment, and accordingly it will act in the crop transport robot, as well as a mechanical arm, this cutter unit. Based upon that, it will act as an activator here. The physical action will be takes place at this moment. So this kind of forest mapping robots and all will be very helpful in the monitoring of crop transport and the mechanical arms, then some cutting of the some grasses, and some various activities which is going to be monitored in the forest side. And from the remote area, we can control these simple robots from the user end side. Now, the energy protection and storage. It is related to the global interest of securing the availability of the electricity while reducing climate and environmental impacts. So, in such situation, smart grids, for example, it implies micro generation of the electricity using affordable photovoltaic panels. In addition, smart grids also require new types of energy storage, both for the grid itself for emerging technologies such as electric vehicles. Yes. So, energy protection, the electric vehicles that rely on increasingly efficient battery technologies will be used in the electric vehicles. Then the wireless sensor networks will increasingly rely on different energy harvesting technology and also rely on new miniaturized battery technologies and ultra capacitors. So, which is having the small battery with the small capacity of the power supply. And at the same time, these technologies will be enabled to keep the battery backup properly. Now, the trends in information and communication technologies. So, the trends in information and communication technologies generally in IoT, sensor activities and tag functions as the digital interface faces to the physical world. So, these tags used such as RFID provide the means to put electric identities on any object and can be cheaply produced. Embedded processing is evolving not only towards higher capabilities and processing speeds, but also extending towards the smallest application. So rapid deployment of cellular 3G and 4G or long-term evaluation, that is LTE systems on the global scale. These systems provide ambiguous and relatively cheap connectivity with the right characteristics for many applications, which is including low latency and the capability to handle large amount of data with high reliability. Software architectures, during the software development, the techniques from what were originally closed environment towards the platform and the web paradigm and using a service oriented approach. By extending the web paradigm to IoT devices, they can become a natural component of building any application and facilitate an easy integration of IoT device services into any enterprise system that is based on the SYA. So automatically any kind of application will be facilitated with the enterprise system that is based on this service oriented approach. So in continuation to this, open APIs also allowing the components to be combined together in multiple different ways by multiple developers who develop the platform or install the services. And at the same time, the cloud computing is also one of the greatest aspect of the evaluation of ICT for IoT, as it allows virtualized and independent execution environments for multiple applications to reside in isolation on the same hardware platform. And usually it is in the large data centers. Then the data processing and intelligence software, which increase a role to play the IoT solutions. Then the big data, the size of data sets are available, increasing number and size of data sets that are available for the companies and individuals to collect the platform analysis. So decision support or even decision making systems. So it becomes very important in different application domains of IoT, as will the set of tools required to process the data, aggregate information, and create knowledge on that particular data analysis to take decision and give the proper solution on the IoT connected devices to take necessary action based upon the predetermined logic. Thank you very much. Thank you.